Now, earlier we talked about the try except block. Imagine we have two divisors, 2 and 0, and would you say for d in those two numbers, 2 or 0, try do what? Print 1 divided by d. So 1 divided by 2 should be half, and 1 divided by 0, good luck. So then, in order to prevent that the code will crash, you put try and except block. Is try and except block something new? No? Yes? Try except, yeah. So now, if this is true, it will go, and that's why we get the half here. The next time, 1 divided by 0, it's a problem, right? So it goes into the except block. Nice joke, right? Okay. Run it. All right. Who's familiar with NumPy? Yes?
Yeah, I messed with it a long time ago. But,
Okay. NumPy is super powerful in terms of mathematical calculation. It's actually super optimized. It was written in C++ and Fortran, and really invested a lot of time using it and building it. Now this module called web browser, it's actually open any website from the cell. So I'm saying import web browser as WB. WB is just a soft alias. It's nothing fancy. And then instead of using web browser, I can use WB. So WB dot open, and this is actually the link to the NumPy. So when I do that, it takes me into the NumPy page. It says NumPy is a fundamental package for scientific computing with Python. It contains whatsoever. A powerful n-dimensional array or object. Those who really doing a lot of algebra, linear algebra, I will show you a few examples. How do you deal with those ones? Now, the first thing, imagine we have, that's how we define a NumPy array. So first, import it. Import NumPy as NP. And again, this is an alias for this library / module. Now, x1 is NP array dot array of 1, 2, 3. x2, same thing. It's exact. By the way, x1 and x2 are exactly the same. So they are pointing to the same place in the memory. Now, dot product, very simple, right? So NP dot. This dot is the, it's an object. So x1, x2, what's the dot product of 1, 2, 3, 1, 2, 3? It's 1 plus 4 plus 9, 14, right? And see, that's what you get. Now the cross product is x1 with x2. What's the answer? 0, because the angle between the vector and the vector itself is 0, and then the sign of 0 is 0. What you get 0, 0, 0. But again, it's a vector, okay? Or yeah, it's not a scalar. This is a scalar. This is a vector.
What's the cross mean?
Oh, cross product?
Oh, this cross.
Yeah, cross product.
Oh.
The cross product in math, in linear algebra, you have two vectors, and then it's how do you? There are two ways to. Well, there's the dot product if you multiply two vectors to get a scalar, or you get a vector. So the cross product, it's you take the magnitude of the x1 times the magnitude of x2 times the sign of the angle between the two vectors in space.
Oh.
Yeah. Okay. Now, also, what we can do with NumPy is creating the range is in Python or regular Python. In NumPy, you call it a range of 10, and you can reshape it. So now this gets me one-dimensional array, which is 0, 1, 2, 3, 4, up to 9. Now I can reshape it into 5 rows and 2 columns, right? Now, slicing and dicing, I know that's how you slice and dice in NumPy. So remember, x1 is 1, 2, 3. So I'm saying x1 where x1 bigger than 2. So it goes to an x1. X1 is 1, 2, 3. So I'm saying it's bigger equal to, so the 1 is gone. So I have, that's the x1, and that's what I get, x1 where x1 is bigger than 2, bigger equal to becomes 2 and 3. Right? Not only that, you can even slice it in a more complicated way, such as applying, some conditions here, like x1, or try this. What does that get me? X1 bigger equal 2 and x2, x1 less than 3. That gives me false, true, false, right? Because this is a Boolean thing, right? What's left? 2. Now, one more thing. Those who are, anyone remember what's a transpose of a vector? So you take a vector of a row vector, becomes a column, right? So x dot t for transpose, it takes it actually. It's shown in the screen as a same thing, but it's basically it's the opposite. Now, when we have two vectors, and you're trying to apply them and multiply them as a matrix, what we know? We know that the columns of the first metric should be like the rows of the second metric in order to have a meaningful product, because not every two matrices can be multiplied, right? So we have 1, 2, and 3. Now, this is again could be a matrix, right? But the way to get this multiplication meaningful, you need to have 1, 2, 3. So this is 1 times 3, and this is 3 times 1. The important thing that these dimensions should be exactly the same, and the total dimension here will be what we have. It's just 1, right? So let's do some calculations here. So if I'm saying x1 times x1 dot t, that's what we get. So the way to multiply those ones, it becomes 1 times 1 is 1. And 2 times 2, and then 3 times 2. That's what we get as an answer. Oh, of course. I was thinking about discount. All right. Okay. Now, one of the nice things about NumPy matrices, you can find the index of the minimum, the index of the maximum. That's how you get it. Print x1 dot argmax. It gives me the index where the minimum sits, and the argmin gives me where is the minimum of that value of that in that array sits. So that's why I have 2 here, because I have 1, 2, 3. So the maximum is at 2, and the minimum is at 0.